let's take a look at this. If you approach this problem and view it as the difference of squares, we have 25, which is 5 squared, minus, so that's our base. And this next expression, we don't have to expand it out to know it's a perfect square, right? They give you the base. It's a binomial base squared. So we have this form of a squared minus b squared. So it's going to factor into the sum and difference of those terms that are being squared. So when we factor this, we're going to have two factors. The first term is a 5. The second term is a binomial 2z plus 5. Now notice, if your second term is the binomial, it's a good idea to put it in grouping symbols. That way you recall or remember to distribute your negative correctly. So this factors into the sum of terms times the difference of those terms. All right, so in this first set, we're just going to combine our like terms and rewrite our factor in standard form. So the 2z comes first. 5 plus 5 is 10. So there's our first factor. In the second factor, we're going to distribute this negative. Remember, a negative or subtracting is equivalent to adding the opposite. So I'm going to turn this to an addition, and I'm going to change the sign of each term. So here we have a negative 2z if we rewrite our factor in standard form. 5 plus a negative 5, or 5 minus 5, cancels. So here is our set of factors. And so now when we look at this, we do have a common factor that we need to remove from this first set. Taking out a 2, we're left with a z plus 5. This negative 2z still remains. And so now we can combine our monomial factors here. So 2 times a negative 2z gives us a negative 4z. And then the z plus 5 is the binomial factor. So that would be your simplified form.